Welcome student. So in previous session we have learned about ideal gas and how ideal gases differ from real gas. In today's session we are going to see about concept of mean free path. मीन मतलब होता है एवरेज निकालना, जैसे कि हम प्रैक्टिकल्स में बहुत सारे रीडिंग्स लेते हैं और उसकी एक फिर एवरेज वैल्यू निकालते हैं. सेम लाइक दैट वी आर गोइंग टू see about mean free path. So we are interested to find out mean of particular free path. So here we have one diagram you can see on your screen now. So if we consider here, one single molecule is trying to transfer from one place to another place here. So this is going to be travel from one place to another place. So yes, as we know that in a gas will move in a random motion but always travels free path. So always remember this, gas will travel in a straight line only, you can see here. So it is that's why, because your gas molecules are traveling straight along a straight path, that's why zigzag motion will be there. Now kinetic energy or the kinetic theory of gases says that whatever the molecules are there, they are performing perfect elastic collision, and due to perfect elastic collision, velocity and kinetic energy will be constant. So a molecule is a transfer, you can see on your screen now, molecule is actually transfer through multiple path, 1 2 3 4 5 6 and 7. So we can see here or say here that a molecule is transferred through multiple path, and mean of this multiple path is going to be known as mean free path. So multiple times it is traveling, firstly here to here, then here to here, then this place to this, then this place to this, and lastly it is going to be at this place. So we are actually interested to find out mean of this particular free path, and that is called as mean free path. Hope so you are understanding this. Then average distance traveled by the molecule with a constant velocity between two successive collisions. So between two successive collisions, you can see here, between two successive collisions, average distance transferred by molecules. So this is called as your mean free path, and that is considered as your definition also. So here I have tried to write some detail about your mean free path for molecules or gas molecules. Then one thing is important, that between two successive collisions the molecule move along a straight path with constant velocity. You have to remember this thing always. So second thing is that whenever molecule is try to transfer from one place to another place, it will face two problems. One is size of that particular molecules, or not particular but size of molecules which are present in that container, and density of that container. So if low density is there and high density is there, what will happen? So if low density is there, molecule will easily transfer, so many paths will be there, and that's why mean free path will be maximum. In high density, molecule is not that much easily going to transfer, so many collisions will be there, and that's why if so many collisions are there, mean free path will be less. So as I said earlier that two molecule will faces two problems. Second one is size of molecules which are present in this container. So this one is small, but this one is bigger. You can see here, this one is bigger as compared to black one. So whenever if size is small, molecules will less collide with each other, and they will transfer easily throughout container. But molecule size is bigger, they will collide with each other, and mean free path will be less. So on the basis of these two statements, first one, that higher density more will be collision and smaller will be mean free path. And second one is, if size is varying, then lambda is going to be inversely proportional to diameter. So in these on these two statement I can write two equations. So first one is lambda is equal to, first one is lambda is inversely proportional to rho, which is known as density, and second one is lambda is inversely proportional to 1 by d square. So these two equations we have now. So on the basis of these two equations we will try to find out another equation. So yes, here lambda is inversely proportional to d square because it depends on the cross section of a molecule. So lambda is final equation we will have this one, lambda is equal to 1 by अंडर रूट 2 बाय डी स्क्वायर एन बाय वी. सो एन बाय वी कैसे आया यहाँ पे? सो आई विल ट्राई टू एलेबरेट इट मोरली. सो सी हियर, hope so you will understand it. So yes, we have got two equations, that 1 by d square and rho, right? Then what we are going to write here, instead of this proportionality sign we will write 1 by under root 2 pi, d square will be same, and we have mentioned rho's value, that is in bracket n by v. So like this we will able to get our equation. So hope so you understood it very well. So in today's session we have learned about mean free path, and mean free path is nothing but average distance transferred by a molecule with a constant velocity between two successive collisions. So between two successive collisions, whatever the average distance is transferred by that particular molecule at a constant velocity, it is called as mean free path. But while transferring from one place to another place, it will face two kind of problems. First one, density of that container. If density is high, collision will be high and mean free path will be less. And about size, if a molecular size is less, that particular molecule is able to move from one place to another place very easily. If size is bigger, it is not going to be move that much easily, and mean free path for bigger size it will be less. So eventually we will get one equation here, lambda is equal to 1 by under root 2 pi into d square by n by v. So 2 square अंडर रूट 2 पाई, इट इज़ गोइंग टू बी प्रोपोर्शनलिटी कांस्टेंट, डी स्क्वायर ये आपकी साइज की वैल्यू है, और एन बाई वी दिस इज योर रो. So hope so you understood up to here very well. So yes, you don't have any doubts and you don't write anything in comment box. So from onwards I am not going to ask you any doubts and any questions. So if you are watching this, that is also more than enough for me. Thank you for watching this.